Hi everybody. So we are going to finish up section 7.2 when the section on inverse trigonometric functions by just doing some more calculations where we they're a little more complicated than finding what's the sine of the inverse sine of x. What about the cosine of the inverse sine of x, or something like that. Now the good news is that once you unravel the definitions, mathematically the actual problem, the mathematics behind it is exactly the same as the problems we had earlier, where we have given, we know the sine of an angle, and we know what quadrant it's in. We should be able to find the values of the other 5 trig functions. And that's what's going on here. So, for example, if we want to find the cosine of the inverse sine of 1/5, let's give this inverse sine of 1/5 a name. We'll call it theta. And we know that if theta is equal to this, there are 2 things we know: that the sine of theta is 1/5, and theta is between negative pi over 2 and pi over 2. Okay. All right. And because so this says that theta is either in the 4th or the 1st quadrant, and because the sine is positive, it must be in the 1st. And because it's in the 1st, that means that the cosine of theta must be positive. Okay? So we know that this is equal to the cosine of theta. And we know that this, by the fundamental theorem, the fundamental identity, we know this is going to be the square root of 1 minus sine squared of theta. And we know it's the positive square root because the cosine is positive. And then this is just going to be the square root of 1 minus 1/5 squared, which is the square root of, we can write this as 1 minus 1 over 25, which is the square root of 25 over 25 minus 1 over 25, which is the square root of 24 over 25, which, oops, sorry about that. And we can finally reduce this to the square root of 24 over 5. And so that would be the value of this. If you don't like this much square roots, you can also just start with the fundamental identity. You can just say sine squared plus cosine squared of theta equals 1, and plug these values in and go from there. But you'll end up doing about the same amount of work. But that's how we do it. Let's look at the next example, the sine of the inverse cosine of 2/7. Let's call this theta. So the cosine of theta is 2/7. And theta is between 0 and pi. And this tells us theta is either in the 1st or 2nd quadrant. And because the cosine is positive, that means in the 1st quadrant again. So the sine of theta is going to be positive because we're in the 1st quadrant. Okay, so so we'll do it the other way. We know that the sine squared of theta plus cosine squared of theta equals 1. So sine squared of theta is 1 minus cosine squared of theta, which is 1 minus 2/7 squared, which is 1 minus 4/49. And this is 49 over 49 minus 4 over 49. So this is 45 over 49. And so that's what sine squared is, and because sine is positive, we take the positive square root. So the sine of theta is the square root of 45 over the square root of 49, which is 7. So that's our answer. All right. Let's look at the next one. Make a box around this. Here we have, again, look, if we call the inside expression, we call that theta. Once again, theta will be the inverse cosine of something, which is negative 1/4. So the cosine of theta is negative 1/4, and theta is still between 0 and pi. And first or second quadrant, the cosine is negative, so we're in the second quadrant. Okay, and in that second quadrant, we know the tangent is negative, and so is the sine, of course. Or actually, I'm sorry, the sine is positive, but the tangent's negative. So let's go. Probably the easiest way to do this directly is, we know the relation between the secant and the tangent. The secant of theta, of course, is going to be the reciprocal of the cosine, so that will be negative 4. And since the secant squared of theta is 1 plus tangent squared of theta, we know that, well, maybe we should just go and say tangent squared theta is secant squared of theta minus 1. So this will be negative 4 squared minus 1, which is 16 minus 1, which is 15. And now we take the square root of both sides. And so because the tangent's negative, we have to take the negative square root. So it's the square root of negative 15. Okay. And tell you what, why don't I pause the video and I'll let you do number 4 by yourself. This is the cosine of the inverse tangent of 4/3. There. Okay, let's see how we did. Hopefully you'll let theta be the inverse tangent of 4/3. So tangent of theta is 4/3, and theta is either in the fourth or the first quadrant. But because the tangent is positive, it must be in the first. So the cosine is positive. Okay, now we use the relation involving the secant and tangent, because we already know what the tangent is, so we probably should use this one, use one of our known values. So secant squared, we know what secant is, we can just take the reciprocal and get cosine. And so secant squared, when you plug everything in, you get 25/9. Take the square root of 25/9, which is 5/3, take the reciprocal, and so 3/5 is the result. Okay, great. Now I'd like to do the next page where we have this, we basically do the same thing but without numbers, and we get some algebraic expressions. So let's say if we just wanted to write an expression, the cosine of the inverse sine of x as a algebraic expression, how would we do that? Well, we can again let the inverse sine of x be theta, so we get that the sine of theta is equal to x. And we won't worry right now about whether this is positive or negative, but we do know that the cosine squared of theta is going to be 1 minus sine squared of theta. Okay, so that will be 1 minus x squared. Okay, and then so the cosine is going to be, well, we could take the cosine of theta then will be plus or minus the square root of 1 minus x squared. However, but theta is, this kind of implies that theta is still between negative pi over 2 and pi over 2. So that means the cosine has to be positive for the first. So this is actually going to be just the positive square root. So this is just going to be the square root of 1 minus x squared. Okay, so keep that in mind. Tangent of the inverse cosine of theta. If we let the inverse cosine of x be theta, this means the cosine of theta is x. And then the secant of theta will be 1 over x, and since we know that the tangent squared of theta is going to be secant squared of theta minus 1, we just rearrange the fundamental identity. We know that secant squared is 1 plus tangent squared, so we subtract 1 from both sides. And so this is going to be 1 over x squared minus 1, or 1 over x squared minus 1. And then we can take the square root of both sides. So this is going to be, so the tangent of theta will be the square root of 1 over x squared minus 1. Okay. And let's see, let me just make sure I didn't do another braid part here. I think I might have, but let's see. Right. Okay. Nope, I actually did this correctly, and I did it incorrectly on my notes. So how about that? All right. About the sine of the inverse tangent, let's let theta be the inverse tangent of x. So the tangent of theta is equal to x. We're looking for some information about the sine of theta. So we actually have to do a little bit of work here, not too much. We can probably the easiest way to do this is, well, we could, take your pick. Where we could try to, how did I do this in my wonderful notes? Let's take the cotangent first. The cotangent's easy. That'll just be the reciprocal of that. And then we do that, we know that the cosecant squared of theta will be 1 plus cotangent squared of theta. So this will be 1 plus 1 over x squared, which is 1 plus 1 over x squared. And then, so that means if we take the reciprocal, well, take the square root, this will be the cosecant of theta is going to be the square root of 1 plus 1 over x squared. Okay, and then that's, of course, that's going to be the cosecant. The sine is going to be reciprocal of that. So let me just, so the sine of theta will be 1 over the square root of 1 plus 1 over x squared. Okay, and if you want to simplify this, you can. If you play around with this, this will actually be equal to x over square root of 1 plus x squared. See if you can see if you can do this yourself. I think the key here is just multiplying and dividing by x, and then playing around with this. Do a little algebra. But that's what the answer is. And then I will just tell you for the secant of the inverse sine of theta, I am just going to tell you that the answer is going to be 1 over the square root of 1 minus x squared. I'm going to let you work on this yourself and see if you can figure out why that is. Just do the same thing. Let theta be the inverse sine of x, and then play around with some identities, and then you'll see if you can do that, see why that's true. All right? So watch this video again if you need it. Get lots of practice, and I'll see you next time.